Hello, everyone. Welcome to freepilotgroundschool.ca. This is the third preparatory ground instruction lesson on ancillary controls. And there's no real lesson, just like on exercise 2, where you're going to be showing up and just doing this lesson. It's kind of incorporated into a number of introductory lessons that you're going to be covering. Prior to your flight, one of your first flights, you should be taking a look at this exercise in your flight training manual, where we will just be discussing things like the mixture control and the carburetor heat control. Let's begin by discussing the carburetor heat controls. If you completed the ground school already, you should be familiar with the carburetor heat. The carburetor heat uses hot air from around the exhaust to heat up the air in the carburetor. So hopefully you will recall that the carburetor has a venturi in order to kind of suck the fuel into the airflow that goes into the engine. Because this venturi has a lower pressure, and when we reduce the pressure of a fluid, we also reduce the temperature. So even though it might be plus 5 degrees outside, the venturi could cause a reduction in the temperature in the induction system to below 0, which would freeze any moisture that's in the air. Carburetor icing is the most common cause of engine failures. And the carburetor ice is worse at high humidities and temperatures above and below freezing. So minus 5 to approximately plus 10 degrees Celsius. This is really important that you know. A lot of people think, oh, you only get carburetor icing when it's below 0. But when it's really cold out, you don't get carburetor icing because the moisture is already frozen. It's when you have liquid water vapor in the air, let's say plus 5, plus 10 degrees, and then it gets cooled down, and that liquid water vapor freezes inside the venturi and on the throttle valve. You want to use the carburetor heat at low power setting and when the engine is running rough. Keep in mind, if the engine's running rough from carburetor icing, and you pull the carburetor heat on, the engine will run even rougher because you have melting water going through the engine. And it's very important that if this happens to you, you keep the carburetor heat on until the water is melted. One of the clues about how badly you might get carburetor icing is to look at the temperature dew point spread. If it's narrow, then you have high humidity. Keep in mind that using the carburetor heat control on the ground is probably not a good idea because the carburetor heat air is not filtered. It doesn't go through the air filter, so you end up getting dust and things like that in the engine. If we look on the right, this is an example of kind of the risk, the carb ice potential. This image, I believe, is from Bold Method, so you can check out their YouTube channel and their website. So you can see when we have a narrow temperature dew point spread, that means kind of a high relative humidity. That's when we have the most serious or the highest probability of getting carburetor icing. Just like our discussion on the carburetor heat, the mixture control has been covered in the engines and systems lessons in your ground school. But we'll just review it here quick. The mixture control adjusts the fuel-air ratio. It affects the fuel consumption of the aircraft, the power, and the exhaust gas temperature. The mixture control is the red knob just to the right of the throttle control. So you can see on the top there, the black knob is the throttle, the right is the mixture. This is called a vernier type mixture control. So you can push the button in the middle and pull it out suddenly, or you can turn it for fine adjustment. It kind of slowly screws its way out. On the bottom right, we have a twin engine aircraft. The mixture controls are the two levers on the right for the left and right engine respectively. The reason we have a mixture control is because at higher altitudes, the air is less dense. If the air is less dense, we want less fuel going into the engine. And so we pull the mixture control out. This reduces the fuel going to the engine by closing the metering valve inside the carburetor. As we're doing that, the exhaust gas temperature, EGT, will increase because we have less fuel in the mixture to cool the engine. It's very important that when you are flying, especially at higher altitudes and longer distances, you always lean the mixture. If you don't lean the mixture, you will not get the fuel economy that the manufacturer has published, and there is a possibility that you will run out of fuel. For takeoff and climb, we generally use full rich mixture to improve cooling characteristics on the engine. And in cruise, we're going to lean the mixture until the power drops. So we have full rich. We're in cruise, we've set the power. We're slowly going to turn the mixture control out. We will see an increase in RPM. So the engine's running more efficiently. And then once we lean it too much, that engine RPM will start rapidly decreasing. And then at that point, we just enrich it. It's also important, let's say we're at high altitudes and we start a descent. We want to enrich in the mixture as we descend so that we don't end up with too lean a mixture down low. Lastly, let's talk about cabin heat controls. Aircraft are notoriously terrible at maintaining any sort of temperature control. It's super simple. It's not at all like a car. You just pull a knob out and that kind of opens an air valve to get hot air either to your feet or defrost to the windscreen. You'll see it on the bottom right hand side underneath the right control yoke, and you just basically put them on and off, and they're pretty simple to use. While we're talking about the cabin heat control, though, it's important to note that there is a possibility that you get carbon monoxide poisoning. The way that cabin heat works in an aircraft is there's a shroud around the exhaust, and the hot air from around the exhaust gets then put into the cabin. If there's for some reason a crack in the exhaust, which has happened, you could end up with carbon monoxide poisoning. So if you're flying along in the wintertime and you have the heat on, and all of a sudden you get a headache or you're lightheaded or something doesn't feel right, something to worry about. In fact, it's actually such an issue, or I shouldn't say it's such an issue, but it is a possibility with tragic consequences that it's actually required on most inspections that the exhaust is inspected by an aircraft maintenance engineer to make sure it does not have any cracks in it. Let's review the carburetor heat control. Heats the carburetor and melts ice. You generally want to check it every 15 minutes, especially when it's cool outside with high humidity. In mixture, the mixture control controls the fuel-air ratio. We're going to lean that mixture in cruise. That concludes this lesson on ancillary controls. You're going to be spending some time with your instructor when you're flying and using those controls, kind of a bit on every flight.